Welcome back once again, everybody, to the Robotic CAD Path Programming for Casting Finishing workshop. I'm Sam Monach once again. Today we're going to start working in more, now that we have a robotic cell down and we have some initialization programs, we're going to start to work into some operations we can actually perform now that we have this robot set up that we can use for some of our finishing operations. So today we're going to start with how we're going to create some of these finishing operations. Our first one up is going to be how we're selecting operations. In this case, in the next session, we're going to be using our second robotic cell. However, in this one, we're going to start with using our grabbing robot in part to process operations. So part to process is with the robot, you take the part and you bring it to some sort of operation. Usually you'll have some sort of either fixture or gripper that's going to grab your part and then carry it into each operation. It works very well for light parts, and it's very nice since you have access to the entire part because you're gripping it in a specific way. You can get access to cutoff, edge grinding, or grinding on any external surface. It's very nice for that. However, if say you have a very large part or awkward part, you can also begin to work into process to part operations. In this case, you have some sort of robot or some machining arm, then you're taking it to a static part that is mounted to a surface. So in this case, you can do things where you have access to internal grinding or accessing those heavy parts or different, more precise operations that you can handle with robots accessing your entire larger part. But for today, we're going to start with just doing some part to process operations. And for any part to process operation, our first step is going to have to be a grab operation. So how we're going to actually do this initial grab is we're just going to use some of the tools we have available in offline programming. So because we have our geometry all set up and our part located in a specific location that we know ahead of time, we can now start to work into how we're going to grab the part. So the first thing you're going to do is under your program tab at the top of your toolbar, you're going to select the Teach Targets on Surface option. You can see kind of a little drop down there. You're going to get a pop-up window that's going to show you a few options of how to orient your robot and arm in order to do these grabs. For us, we're going to adjust our wheel so that our gripper is now facing up. So it's going to be sandwiching both the gripper jaws around our part on the table. And once you have that lined up, we can then go on to move our cursor. So you'll be able to move your tooltip of your cursor over to your part. Now, because you have that 3-dot option selected in that pop-up window, you can select midpoints of lines. In this case, we're going to grab the midpoint along that edge that you can see on your part there. That's going to let us grab right in the center where it's located between our two fixture rails. And as you can see it there, it'll line up. Once you have a good position selected, simply just click and it'll lock in on that target right on the part edge. This actually helps us a lot to get our part orientation, our gripper orientation down for really quick part grabs. All right. So now that you have that target, we can start to just work around how we're going to get, excuse me. We can work around how we're going to get our approach and retract points for this grab operation. So looking at our part and how it's fixtured, we can see that in order to grab this part, we're going to actually have to come in from the side to grab it, and then we're going to have to go up to get away from our fixture. And we can do this in a couple ways, but we'll actually be doing it by adjusting our X, Y, and Z location on our actual robot. So if you want, you can double click on the robot arm itself, and you'll get a pop-up window like you'll see on the bottom right image. Has all the options of how you're going to operate your robot. In this case, we're going to make an approach point by just moving our robot away in the -X direction. And you can set that to 200 millimeters, either by just typing in -200 into your dialog box or by simply using your scroll wheel. Excuse me. Once you have that location selected with your robot, you can see your robot move physically back to that location. You can suppress or you can select the create target icon up on your top toolbar. And then if we want to make our retract point, so we've come in, grab the part, now we're going to move straight up. We're going to use the same thing with our robot controller to move it up plus Z200. To let us go back to the same location, you can simply double click that first target you made for the grip location and you'll snap right to it. And then you can move your robot up 200 millimeters plus in Z. Since we're referencing everything from that corner of the part, you can use it relative to that location. And then you can create your new target for your retreat point. All right, so now we have our 3 targets and we can use them to make our grab operation. So it's going to take place not in the order we made those parts. So kind of one of the fun things we can do to make things a little easier on ourselves is we'll use order and renaming to help us keep track of everything we're doing. So in this case, what you're going to do is you're just going to drag and drop target 2, the second one you made, above that very first target that you made. So then it's going to go from your location outside of that part, going to move in and then going to go up. And if we select all those parts, clicking on the first one or on target 2, then shift clicking all the way down to the bottom one, you can then right click and then rename group. In this case, we're going to rename it to grab. In this case, you'll get a list of all your targets numbered out in the order you have them in your tree. So 1, 2, 3. Just an easy way to keep track of how your operation is going to take place and what you're going to do at each of those steps. This will help later as you get to larger, more complicated operations. You'll be able to keep track of exactly what operation is doing what as you move along. But anyways, so now that we have our part, locations to grab, we're going to actually now in the cell physically grab the part. And we're going to do that in 2 ways. We're going to have a signal that's going to be sent by our robot to grab it in real life. And we're going to have an action inside of our virtual model to grab the part. That way we can keep track of where it is in space whenever our robot has this part held. To start, you need to make a grab program for this part. So now that you have your 3 targets, you can simply select your 1, 2, 3 targets, and then just hit the create program icon at the top of your toolbar. You can see it's highlighted there in red. This is just a really quick way. It's a really quick way you can get all of your targets grabbed into a coherent program. So it's going to basically create a program with 3 movements. Your first movement is going to be a J move, so a joint move to get your joints for your robot all lined up. It's going to be followed by 2 other L moves, so linear moves, so you know exactly how that robot's going to move in and then move up straight along those the lines between each of those points. Once you hit that create program, you're going to also then, once it'll pop up with that new program at the bottom of your tree. And if you just simply right click on your new program, we can rename this now to our grab program. So we can keep track as we get more and more programs listed off. So now that we have our grab, this is where we're going to start building in how it's going to be physically grabbed in our cell. So if you just hover over or select your second L move to the grab motion, make sure you double click on it so that your robot moves to that location. And then you'll be able to right click on, or sorry, not right click, select the create event icon at the very top of the screen. It's that little circular arrow icon you'll see. So this lets you do a lot of different things inside of your cell. At least in the case of this program, this is how you're going to attach and detach objects as we grab and drop them. Also lets you show and hide different objects. Say if you were to be running a saw versus not, you could have a blade show up to show this is where things are going to be, or if you're going to be doing any other piece of equipment that moves, you can have it show or hide. In this case, we're going to be doing a attach objects, and we'll do this with a with reference to our TCP versus object list. So you should see an option for measure distance as. In that dropdown, you're going to select TCP versus object surface and then list in quotation marks. This just lets us select the 2 objects that we're going to grab with the robot. Otherwise, if you're going to do this program and you were to just grab at random, it's going to start grabbing objects that are nearest to the tool center point. So in this case, we're just telling it we only ever want to pick up these 2 parts. So now that you have your operation ready to go, you can actually run through that program once. In this operation, you can see if you double click that program to run it, so simply by clicking on the program in the tree, or you can right click on the program and select the run icon. But if you run that program, you'll see it only picks up one object. Just a limit of the program that it only grabs one object at a time. So since we're going to be working with both of these objects in the future, you're going to need to select the grab program again, and you'll get that second object as well in your pair of grippers. All right. So now that you have the two objects being held, we're going to want to actually be able to do this on our robot itself. So in order to run this on the robot, we're going to be using a digital input, so a signal that we can send from our robot controller to our gripper to tell it to close. Just kind of one of the common things we can work with on our robot. In this case, you're going to, if you select your second L move and you select the IO icon on your toolbar, we can send the signal that we want. We'll right click on that new instruction that you made. We're going to modify it, and we're just going to set it to, so when we select to modify it, we're going to set it to IO number 9, and you just set the value to 1. And just make sure it's set to set digital output. That way we're sending that digital signal. It's an on-off signal to the thing that it's going to fire. And that's going to cause our gripper to close. In the case of our gripper, it does take a moment for that gripper to close onto our part. So what we're going to want to do is also add a delay or a wait to our robot. If you don't send this wait command, your robot is just going to simply be moving through its motion while that signal is running and while the jaws are closing. This timing varies robot manufacturer to robot manufacturer and where it happens in the motion. By setting up this wait program, we know exactly where that close is going to happen and how long it's going to take. So if you hit the pause icon at the top of that toolbar, you're going to be able to get a pop-up that says, if you right-click on that icon that now is made in your program tree, you can select modify, and that's going to let you adjust how long it takes. In Robotic, it's timed out in milliseconds. Some other robot manufacturers will do it in whole seconds, just to make it simpler on you. In this case, we can just set it to use 2,000 milliseconds to do our math to set it to 2 seconds. And this way, it'll have enough time for our jaws to close and pick up our part. All right. And then one final thing we're going to do in this robot program is we want to set our control speeds so that we're able to do this operation quickly, but without a lot of danger for collision or damage. So in this case, we're going to be setting a very fast speed to be moving away from our plate, and then a much slower speed that we can do while we're doing our grab program, our actual grab. So if you select in your tree just below or just on your set tool command, you can scroll down and select your add instruction command. And then from there, you're going to go and select your set speed. From there, you'll get a pop-up that looks like the icon on the bottom, and we're just going to set it to 1,000 millimeters per second. So it's going to be moving fairly quickly when it's going to grab, then it moves slowly when moving into the part to grab. And how we're going to set that speed? First, of course, we're going to also have to set a rounding instruction. Forget about that too. The rounding instruction, so you'll go to your, similar to how you set that speed, you'll go and set a rounding instruction as well. In this case, we're going to set it to 10, which is a small arc, which is going to let us move still reasonably fast. And then with our new rounding program, we have 2 of the commands we're going to be using a lot if we're going to be moving in and out of parts. All right. So as we move on, you're going to be getting so you'll have your 2 movement speeds already. So what we're going to do is simply just copy and paste. So if you select your 2 move speeds, both your move speed and your rounding, we can simply copy and paste those down. So what we're going to do is we're going to place it just after our approach point. So our grab 1 location, that move J, we're going to paste it there. So we have our new set speed and rounding instruction. We're also going to set it to after our grab command. So then we'll be able to move away from our pad very quickly. And once you have those 2 pasted in, we're just going to modify our first set that we copied in. So all you'll have to do is right click on your set speed instruction, and we're going to set it down to 50 millimeters a second. That way it's moving much slower. We can monitor it, and also we're avoiding any dangerous collisions in case there's something unexpected in that area. And beyond that, we're also going to set have to change our accuracy so that we come to the exact point we expect. And we're going to set our value to -1 on the accuracy or rounding command so that we move exactly into our position and it'll pause briefly in addition to our pause. And this way we avoid any harsh collisions on our robot. All right. So now you should be having your part. It'll have it in the jaws. Now we're going to get ready to do an actual operation that's going to be removing material in our cell. So in this case, we're going to be grabbing our part and we're going to be removing the gates and riser that you can see on the part itself. However, to start, we're going to make things just easier on ourselves, how we're going to be programming. So we're going to first select our the create program icon, and then you're going to hover over your JMove to home and select the JMove option. So the thing we're going to do is we're going to start up our saw, and the first thing we want it to do is make sure our robot is in a safe place away from that saw so we don't have any issues when we're starting up. So we'll move it there first, and then we're going to move on in the next step. We're going to add an IO signal after that JMove. So in this case, we're turning on our bandsaw to allow it to cut our part. Similar to how we did with the gripper, we're also going to add a wait command. In this case, it's just allowing time for our saw to get up to speed and get ready for us to do any cuts. This way, it's going to be ready for us, and we're going to make sure it's safe and ready to go. It's just kind of a simple thing we can do when we're operating any outside piece of equipment, just to make sure that everything is ready to go for our robot. All right. Now, to make all of our cutting a little bit easier, so we can move our robot kind of by ourselves, and we can set it visually and just eyeball it in our robot cell, but that's not a particularly accurate way to do things, especially with some of these castings. We have some pre-built-in tolerances where we don't want to line it up exactly, or say based on our stops, we may not hit our location just due to defects on the casting, say with either flash or a large piece of burnt-in sand. It may shift where our part is being grabbed and moved all times. So in this case, we're going to use a tool location that we know about in order to set an exact location where all of our operations are going to take place. So to start, you're going to, if you just select the Kawasaki robot, then you go up to your program tab, you can add tool TCP. You can also right-click on the robot and add tool TCP option as well. So it's going to pop up a dialog box of where our new tool, or you're going to have a new tool TCP pop up on your robot. And if we double-click on that, we can modify its exact location. So in this case, we actually want to set it to the same location as the corner of our part. So by having it on the corner of the part, that's exactly where that cut's going to be when we're removing our risers. Our bandsaw blade location is actually set slightly off of the bandsaw blade just to allow us enough of a safety gap so that we're never cutting directly into our part. So we'll be able to actually use these two lined up exactly. So once you have our TCP frame created, we're going to also bring up the location of our part in the dialog box. It should be being held by the robot. So you should see it in the dialog box for the robot in the tree. If you double click on that, you're going to get its location with respect to the gripper. And then what we'll also do with our gates is you'll take the drop down box of location with reference to, and you'll change it to that same gripper. That way we can just copy and paste over the exact location of our robot, the exact location of our part, so we know exactly where that cut's going to be taking place. In this case, we're also going to adjust our Y prime angle. So it's going to be the second dialog box in your part. And by adjusting that, you're going to get it by -90 degrees. You'll orient the tool in line with your gripper. Otherwise, you'd be doing all of your cuts at a strange angle relative to your gripper in the same frame as that part is located. All right. So now we're going to, instead of using our teach target on surface tool, which lets us do it anywhere on that bandsaw blade, what we're actually going to do is make this a little bit easier on ourselves so that we know the exact location we're using with our robot. To do this, you're going to right-click on your cut TCP frame that's in your tree, you can see it on the right there where it's located next to our cut saw. If you right click on it, you can set it to be our active support frame. This way, all the information we're going to be entering is going to be relative to that frame. And then if you double click on your robot or bring up your robot control box again, you can actually now set our robot to be aligned up with the cut location. So the next thing you're going to do is also right click on your gates, that new gate TCP that you made. One thing just to keep everything straight, you might want to right click on that gate TCP that you just made and rename it to gates. That way you'll be aware of which one it is in your tree. And so if you right click and change name, you should be able to do that very quickly. Then after that, in your robot dialog box, you can actually set the location manually to all zeros. To set it up this way, you'll make sure you have your new tool active, and then you'll simply into the dialog box, enter 0 for your 3 X, Y, and Z locations. That'll snap our robot close to the location of the bandsaw blade. However, sometimes that's going to be unreachable from our current orientation. So the one thing you're going to you may have to do as you're paying attention to it is adjust your angle as you go. That's going to be set up in our next step. Ooh, there we go. So after you have your part swung over and then in line with that bandsaw blade set to 0, 0, 0, you'll notice that it's in line with the bandsaw blade. This is where we want to have our cut operation take place, where we're going to be removing each of our gates. For now, what we're going to do is just hit the create target icon. That's going to create a new target for our start of our cutting point for the gates. The end of our cutting point for our gates, as it's going to be held, pushed through that saw. But in order to actually do this, we're going to have to create a few extra points to be able to use it inside the cell. At this point in the trial, if you're using a trial version of the software, it has a limit on number of targets. So what you may need to do is basically save off a copy of this, and then you'll have to start a new copy just for using the cake cut operation. It's an annoying limit for the trial version, but it's kind of the only workaround you may be able to work with. So if you want to save as and then create a new one, you would have to delete some of the old targets or delete the old programs in order to run from this point moving forward. But we're going to start working with we're going to start working from here to get our 5 gate cut locations that are going to be used for making this motion. Our first one is going to be our approach and retreat points for this cut. So we're going to take from our original location and we're going to move our robot backwards away from the saw. So we'll move it out away from the part back to where our part is just clear of that bandsaw blade. And then we can create a new target in that location. By creating that target there, we know roughly where we're going to start. So we can start moving at a slower speed when we know that we're near our bandsaw blade. Beyond that, we're also going to move even further back. So you'll move even further backwards. I'd recommend using this by simply using your dialog box on your robot, or you can move it in the negative Z direction to get away from our bandsaw blade and keep everything in line with that bandsaw blade as we're approaching the blade itself. After you've created the first retreat point, now you can create your second retreat point, moved even further back. And then also once you have that second retreat point, we can then swing our robot to the side. So the way I would do this is if you use your robot control dialog box, you should have a bunch of sliders that are all linked to your robot joints. You can simply drag your or select the box for your joint 1 and just drag it to the side where you'll see your robot's going to swing over to a location that's clear of our bandsaw. That way, when we ever orienting around our bandsaw, we're going to be clear and we're making sure that we're not colliding as we're doing any repositioning or getting access to new locations. And then once you get to that new location, you can also create a new target there. Once you have that new target, kind of a quick way, we can also make a retreat point. In the case of this operation, we can just move our part away from the bandsaw blade right away. So if you double click on the first target that you had made, you can now also use our XYZ controls and move our part in the positive Y direction. And that way you're going to be moving your robot away from that bandsaw blade or directly away from our bandsaw blade. And now we're going to be clear of it so we can move back to our further retreat point. That way we move nice and slowly away and we're ready for our next steps. By the end, you should have an order of gate cut points. So you're going to have the first one you made, which is our cutting point. The second one you made, which is our start of cut. The third one you made is going to be retreat 2. Fourth one, retreat 1. And your fifth one is going to be the retract point. So in order to actually make everything easier on ourselves, we're going to line it up so that they're all named in a way we can understand. So we're going to start going with our fourth target, then our third target, then our second target, then our first target, and then finally our fifth target. You'll notice in the tree I have just below our image of the robot, I have them all named through gates 1 through 5. So in that case, we're going to click on our first gate's target, and then hold shift and click the last gate's target, and we'll rename that group to gates. In your tree, you may have it set up where it's going, gates 5 through not gates, targets 1 through 5, but we want to have it set up so we know the exact order everything's going to happen in. All right. From there, you should have that list of 5 targets that we're going to use to cut our gates off. Beyond that, we may also, now that we have those 5 points, what you're also going to want to do is we're going to have to have a separate set of points that we're going to use for cutting off our riser. In this case, we don't need to reuse all the points we had previously. So if you need to make a new new robotic cell, we can make a new robotic cell so we can add a couple new points for our riser cutoff. In this case, for the riser cutoff, we're going to do a very similar thing to what we did with our gates TCP. So we're going to start by making a new TCP, just like we did before, either by selecting the option from the Programs tab or right-clicking on our robot and selecting Create New TCP. So this new TCP, or Tool Center Point, is what we're going to be referencing when we do this riser cut. In this case, that location is something we can actually get from our 3D model of our part. In this case, I know the exact location I want of that cut relative to it, so I can then just bring up my riser TCP. So if I open that up, and then I can actually locate with respect to the gates target. So I know where gates is on my part because it's the origin of the part in my 3D CAD. Then I just can measure from that corner to the top of the riser. So I know exactly where I'm going to be cutting when I do this cut off for my gates. In this case, all we're going to do is change the location of our gates TCP to the numbers you'll see in that dialog box on the right, where it's going to be 22 millimeters in X, keeping that 120 in Y, and then 120.65 in the Z. And then making sure our orientation is set right, similar to how we had it before, so that when we locate our part in the cell, the Z location is going to be in line with our robot. All right, then we're going to do the exact same thing we did before with our gate cuts. So you're going to, from your tree, you're going to double click on that new riser TCP. If you want to take the opportunity now, you can rename that TCP to the riser TCP, just so you can keep track of it as we're working around with each one. And then you can also set that as the new active tool. Then with that new TCP, we can do the same thing we did before to locate it on our bandsaw. So we're going to set it to the location via our robot dialog box to 0, 0, 0. With that location set, you'll have it actually embedded in our bandsaw blade, because that is the location of the center of the riser. So in order to actually get our 2 cutting locations, we're going to want to move our part a little backward and forward to get our start of cut and end of cut. So all you'll have to do is select your robot in the dialog box, and then we'll move backward in Z to locate our part for the start of the cut. So you'll see it's located in the image on the right. You have our approach point where we located it behind that riser. You can create a cutting location there. And then if you move the part forward in Z, you can actually locate it beyond the cut between the end of that riser and the start of our gripper, so you can get the second cut location. In actual finishing operations, bandsaw is not always going to be the best option for doing these cutoff operations. You can see in the image on the right, it looks like we're about to crash into that bandsaw blade. However, after this point that we would have done this operation, our gates would have been cut off along with those two risers and our pouring basin from the first cut. So those are technically not there in our imagination, but they are there in our actual physical cell. And then when we perform this cut in real life, those gates wouldn't be there as well. All right. Once you are able to locate a location in front of and behind that bandsaw, we can use those two targets to now create our set of programs that we'll need for both our gate and our riser cuts. The quick way we can do this, so we basically have just a bunch of set of points. We can do the same thing we did before with that grip operation to have a J move to start, and then we can also then continue with the J move to start, and then a series of linear moves to move our part in and out of the bandsaw blade in a controllable fashion. So you can start by doing the gates program, where since we've already lined up all of our targets in the order they're going to happen, all you'll have to do is press or click on gate target 1, then shift click down to gate target 5, and then create the new program icon. Then you'll have your list of targets. In this case, we're also going to click on, so we'll also click on our program that was just made, the new gates program. Then if you can hold control and then click on target 5, we're going to add, or sorry, target 1, we're also going to add that again as a J move at the end. Followed by that, we can then also do our riser program. In this case, we're going to be reusing a few points, but not all of them. In this case, we aren't going to be using gates 3 and 4. So those are the two cutting motions we use when cutting gates off. In the case of this one, we're only going to need gates 1 and 2, and then the 5th one, which is our retreat point. So what you'll do to make that one, you'll simply hold control and then start clicking down the chain of things that we're going to do. So in this case, we're going to start at gates 2. We're going to move to riser 1, riser 2, gates 5, and then gates 1, which is our final retreat point. That way, when you then click your create program, it'll follow the same steps you did when you were selecting each of those targets, and you'll get a program made in the order you expected. From there, you're going to have just a list of targets. So this is where we have to start working in some of the information we know about each of our cutting operations. So in this case, we're using a pretty underpowered bandsaw. So we're going to have to move very slowly through each of these cuts. In our operation, it's a multi-purpose bandsaw where it's used for operations beyond just for the robot. So it's not sized quite the same as you would have for some foundry operations, especially for the thicker gates and risers. However, it does fit within the capacity of what we're doing here. In this case, we're just going to be using some comfortable speeds for movements away from the bandsaw. So in this case, we're going to be moving 50 millimeters per second, 500 millimeters per second away from the bandsaw blade, and then 5 millimeters per second when we're doing our riser cut. So in this case, we're going to create a couple of speed and rounding changes, into our gates and riser program. So we can start out with the gates program. So since those are very thin sections, we can move a little faster. So what you may want to do is simply copy and paste the smooth and set speed programs. If you still have those old programs up, you can just copy and paste those in and change the settings that way. Or you can right click on your tool and then add those instructions manually as you would have done before. In this case, we set our speeds right before the start of our program, so we know how we're going to be moving into this. And then right after our gates 3, which is the approach point right before we start cutting, we're going to lower our speed down 5 millimeters a second. So this is sized based off of the thickness of the part we're cutting, the material it's cutting, which in this case is an aluminum casting, and based on the power of that bandsaw and the tooth shape of our bandsaw blade. Beyond this further, for a lot of more higher volume or different geometry of parts, there are a variety of other cutting options you can use inside of a robotic cell, and also depending on what material you're working with. There's also been great success with using cold saws for this operation, which is a very nice, consistent way. Beyond that, some of the testing we've done also includes things like abrasive band or abrasive cutoff saws, which are less of a great fit for a robotic cell, simply because you have to add another layer of coding knowledge built around the ever-shrinking saw diameter. So for our case, we're using this bandsaw, which is consistently in the same location every time we're going to start cutting. All right. Beyond that, so we'll make our gates program, and similarly, we're going to do the same thing to our riser program. In this case, we're going to actually have to lower that speed even further. So we'll do the same thing we did before, locating speed and rounding changes right before the start of our program, and then right after our cut. You can see in the riser program, that's going to be right after your second riser target. And in our gates program, that was right after our fourth gates target. So that way we're going to be moving very slowly through the cut and very quickly or quicker away from our saw so that we can keep moving our operation forward at a good pace. However, we do need to move very slowly when we're going through these cuts, just to make sure we get consistent cuts and clean cuts when we're using our bandsaw blade, and we avoid any either flexing of that bandsaw blade or crashes that can occur that way. One last thing, when we're doing an operation like this, we're also going to include a signal. In this case, like we did before, when we initialize this program, we're now going to create a signal to turn off that robot, or sorry, turn off our bandsaw blade. So after we move away from the bandsaw blade, which is going to be that fifth move in the case of the riser, simply because our operation is going to go gates to remove those gates, that'll give us access to cut our riser. Then we're going to do that cut on our riser. We'll do our first move away, just so we're clear of the robot, or sorry, our robot is clear of our bandsaw blade, and then we can send the signal to shut down that bandsaw and then move away at a much faster rate. And unlike when we were doing our grab operation or starting up the bandsaw blade, we don't need to add a pause here, simply because there's no interaction between our robot and that bandsaw. So we're in the clear to move away and work on further things. All right. So that's just one of the simple operations we can do with some offline programming. It's a pretty efficient process. Some of the nice things that we get to do with this is we can set very consistent cut lines and commands. And this is all based off of some of the stuff we did our very first time in the first workshop session, where we were setting up the location of our parts and the location of each of those individual tools used by the robot. So by setting those locations precisely to what we found with those robots, we know there's consistent locations that we're going to be using with the robot, and our robot is going to line up those locations with the targets we're picking in our the locations we're picking here in our offline programming. That way, when we're starting to throw in all of our targets, we know where they are almost every time. There's one thing to keep in mind: when we're picking brand new locations with our robot with offline programming, those locations aren't always as well known by the robot, and you can get a lot of inaccuracy just by sending those new locations. However, by using some of these set frame locations, we actually have a much firmer knowledge of where that is in space for the robot. And so by using those locations, we reduce the inaccuracy of each of those targets relative to that location when we feed all this information to our robot when we're exporting and creating brand new programs. All right, just to check in with everybody, you should have a small cell like this, or your cell should look similar to this, where our robot is holding our part, and you'll see a bunch of yellow lines moving back and forth for each of your cut operations as you run through them. This is just a feature that Robotic has, which shows which traces the line of where your TCP moves in space, so you have a good idea of where you're going, where you've been in each operation. That can be turned off and on as well if you don't want it cluttering up your space as your programs get more and more complex. You can simply do that by going down to your programming, right-clicking on that program, and then you should remove the trace of sorry, the program trace. All right. So now we're at a good point for today with some of the operations I want to show you. Beyond that, there's a lot more that can be done with some of your cutoff operations. And this is where a lot of the bulk of your manufacturing knowledge comes to mind. A lot of these feed and speed rates are something that an operator is going to get a feel for by themselves when they're, say, either pushing something through a bandsaw, using a abrasive cutoff wheel. They'll know the rate they can go through those materials, and they'll feel the resistance as they're cutting. Your robot does not have that same sense. So in this case, you're going to want to be using a lot of lookups in tables for what's an appropriate feed speed for when you're cutting each of your materials and for each of your material thicknesses. In the case of a bandsaw blade, you're going to have to be very particularly aware, just because you're having such large thickness, or sorry, section thicknesses, that it's going to affect the rate at which you can cut and the rate at which it can excavate all of the chips that it's making while you're cutting. That's where some other saw blades and coolant techniques come in very handy, where you can excavate all of your chips with the coolant flow and keep your part cool while you're doing all the cutting. There's a variety of different tools that the robots can utilize simply through the signals that you can send from your robot. On our next section, we're going to be getting into a little bit more of the finishing operations, especially into our process to part operations, where we're going to have our part fixtured and locked down to our table here. And we're going to be using our second robot cell, or sorry, our second robot and the second cell you should have loaded to do some more operations to work on our individual parts. In this case, using a powered spindle to get a little bit finer detail and a little more accuracy in all of our finishing operations. But for now, that's all I have for today for this segment of the workshop. I can open up the floor to questions and see if you guys have any issues going so far. Yeah, I know I went through that a little quick. I do encourage you, if you're following along, especially if it's going a little bit of a pace, I would recommend if you can go through your recordings just to get to a place where you understand what you did in the last session and get the cell to look similar to how you would have it in our check-in section, where you're going to have individual parts and then some of the final images of each program, so that we understand kind of the operations that we've gone through to get step to step. Beyond that, if there's no more questions, I'll give you guys a second here. But beyond this, I want to thank everybody for coming to this session today. I look forward to our next session. We're going to be talking a little bit more about our process to part operations. We're going to be handling things just a little bit differently. That's all. Thank you all for today. See you at our next session.